Now in this unit, we're going to start to talk about the sine, cosine, tangent, secant, cosecant, and cotangent functions as being more functions in an algebraic sense, like you would learn in Math 21 or Math 22, things like y equals f of x, like, f of x equals x squared, f of x equals the square root of x. And we're going to do a lot of the same algebraic stuff you would do in a course like that, notably doing graphing, eventually solving equations. So it's going to be really beneficial for us to come up with an idea of the graph of the sine, cosine, tangent, etc. functions. So what we're going to do here is talk about the graph, the pen code that works here, the graph of y equals sine x. Okay, so we're going to get away temporarily from this idea of theta denoting an angle and move on to something that's a little bit more algebraic, just involving x's and y's. Okay, so just to warn you, when we were doing the unit circle and when we were doing angles and standard position, we had this idea of x and y as being like a cosine and a sine of an angle theta. Now moving forward, we're going to think about x as being kind of like our angle. So x is going to be taking the role that theta was before. And because radians are really the more natural mathematical way to think about angles, we're going to exclusively think about x as being an angle in radians. Then y is going to be the sine of that angle. So again, y is the sine of our angle x. All right, I'm going to start out by just thinking about different angles going around the circle, and I'll start with the ones that are on the coordinate axes in the unit circle and try to translate this over to a graph of a function. Okay, so first off, if we are at x equals 0, so x equals 0 corresponds to an angle of 0, then y is going to be the sine of 0 radians, which is 0. If we move on to an angle of pi over 2, y is going to be the sine of pi over 2, which is 1. If we move on to an angle of pi, y is going to be the sine of pi, which is 0. So in terms of our angles, we're starting at 0, we're going up to pi over 2, we're going back down to pi. When our angle is 3 pi over 2, the sine of 3 pi over 2 is negative 1, so that will be our y. When our angle is 2 pi, we're back to where we started. We're coterminal with 0, so our sine value is 0. And then if we want to get a couple more data points, if our angle is 5 pi over 2, that's going to be 2 pi plus pi over 2, so we're going to be coterminal with pi over 2. Okay, so that's going to give us a sine value of 1. 3 pi is coterminal with pi. So it's going to be 2 pi plus 1 pi. So our sine value will be 0. Okay, moving backwards, the angle negative pi over 2 is coterminal with 3 pi over 2. So the sine value is negative 1. And the angle negative pi is coterminal with pi. We move clockwise a half rotation. So the sine value is 0. Okay, and then we just go ahead and connect the dots. So when we do that, and I'll make sure that this matches with what we have with the unit circle in a moment. And then if we wanted to, we could continue this in both directions. Okay, so we're going to get us something that looks roughly like so. I'm going to just smooth this transition out a bit. And negative pi over 2 to make it look a little more like the graph should look. We'll get something that looks like this. Okay, and we can verify this behavior up and down by thinking about what happens to our sine values as we go around the unit circle. So what will happen is if we start at the angle of 0, our sine value is 0, as we move counterclockwise, our sine values are going to increase because they are the y coordinates on the unit circle. They increase up to 1, and then so we're up here, they decrease down to 0 as we approach the angle pi. Then our sine values continue to decrease to -1 as we approach the angle 3 pi over 2. And then as we go back up and complete the circle, our sine values increase back to 0. Okay, and that's going to be one circuit. And then we can just complete that over and over and over again, because now we're back to where we started. Okay, so we see that the graph of the sine function is going to have this sort of oscillating behavior. It goes up and down and up and down. It has the structure of a wave. Okay, there are a few other things that we should notice as well. The first thing is that, to bring in some algebra terms, the domain is going to be all real numbers. So recall that the domain of a function is the set of all the x values on its graph, or the set of all allowable inputs. And we can take the sine of whatever number we want, because any number will represent an angle, and we can take the sine of any angle, and it exists. The range, which remember was the set of all outputs of a function, the set of all the y values of its graph, is going to be y sits between -1 and 1. Okay, or if we use bracket notation, if you're familiar with this, it's going to be -1 to 1, including the endpoints. So that just means that the y values range from y equals -1 to y equals +1. Okay, a few other things that we should notice. One is that we have x-intercepts at all of the whole number multiples of pi. So I'll write that as x equals k times pi, k any integer. We pass through the origin, so our y-intercept is y equals 0. We have high and low points. So we have what we call relative maxima, the high points. And we have relative minima that we call the low points. Okay, and the relative maxima, the high points of our graph, are going to occur when we're at an angle that's coterminal with pi over 2. So pi over 2 plus or minus any multiple of 2 pi. So pi over 2, 5 pi over 2, -3 pi over 2, and so on. We're going to have a relative minima wherever the sine value is equal to -1. So that's going to be when we're coterminal with 3 pi over 2. So -pi over 2, 3 pi over 2, 7 pi over 2, and so on. Okay. A few other things that we want to note. The first is that this graph repeats. So if we were to take this piece of our graph from x equals 0 to x equals 2 pi, we took this piece and copied and pasted it over and over and over again, we're going to get the entire graph of our sine function. And that's because once we take one full trip around the unit circle, we go around 2 pi radians, the sine values reset. Okay, so the fact that we have this repeating behavior means that this function is periodic, and the period is 2 pi. So the period is just a measure of how long it takes for the y values to start to repeat themselves, for the function graph to repeat itself. Then the last thing that we have for this graph that I'm going to talk about is the idea of amplitude. So whenever we have a wave, we want to talk about how powerful that wave is, how big it is. And when we're dealing with a sine or cosine wave, the amplitude is 1/2 the distance from the very highest point to the very lowest point. So 1/2 that vertical distance. So here, for example, the lowest vertical distance is -1. The highest is +1. So that's going to be a distance of 2 units from lowest to highest if we just do the vertical distance. Half of that is going to be our amplitude. So in this case, it's going to be essentially the distance from the x-axis to our apex, or our highest point. Okay, so here our amplitude is equal to 1. Okay, so we go up 1, and then we go back to the x-axis, we go down 1, we go back to the x-axis, and so on. Okay, so here's an overview of what the graph of the sine function looks like. In the next video, we'll look at the graph of the cosine function.